Okay, so I guess this is a presentation about Git LFS or Git large file storage. I guess I'll preface this by saying most of my understanding comes from this much longer talk about Git LFS. I guess as an introduction at a high level, what is Git LFS? Well, like if we look at the features that the source code group kind of maintains, broadly, there's two categories. There's source code management, and then all of these features, and then kind of innocuously, there's Git LFS just hiding at the bottom there. So what it actually is instead of storing the actual files in the repo as normal, they're kind of stored in a separate file, and what's actually stored in the repo is like a text pointer to that file in the separate server. I guess what I actually did recently was kind of explore what happens to or how GitLab handles LFS objects during forking a repository. So I think most of the actual Git LFS things are covered in this video that I'll just share in the chat, I guess. But I guess what I'll talk about is the things that I kind of discovered were different from this video and some of the forking specific things. Oh, there are the Zoom stuff. So when we do uploads, just to explain this one slide from the video, the Git client, when you're adding LFS objects, is actually kind of doing the push as normal, but also through Git hooks is like pushing or like uploading things to an LFS server. So in our case, it looks something like this, where first it's like getting authorization, and then it actually does the upload to Workhorse, and then Workhorse actually saves the file where it's supposed to after getting authorization again from Rails. So this step, and then this part that looks like in the code, it looks like it's doing like, I think the method is called final upload finalize or something like that, and it's not verify finalize. Let's find it. Yeah, upload finalize. It looks like it's actually dealing with a file, but like as the video mentions, Workhorse has actually already saved it. So it was kind of glossed over in the video, but I kind of poked around to see how it actually works. And we have this multi-part middleware that, I guess if you send the right things, there's a uploaded file object that ends up in the params of the request that you can kind of use. And that's kind of part of like this bigger thing where you can have direct uploads. It's actually used across like a number of features. I think there are some other things that use this. See, I guess when it comes to forking, it starts over here. So this is like when you click the create fork button, it's going to call this service, which ends up in, well, you end up doing this. Well, anyways, it ends up like queuing up a worker that like, yeah, it ends up calling this thing, which is just going to link all the LFS objects from the source project to the new fork that's created. I guess to explain that a little bit, On the back end, we have two models, LFS Object and LFS Object Project, which basically represent the LFS objects. I guess that's kind of all I had, but I kind of went through that kind of quickly, so I imagine there might be some questions.
Actually, yeah, we've discussed it quite recently, whether the LFS objects deduplicated when we create a fork, yeah, or whether we use the same amount of storage for the fork. So I guess your message is that they're deduplicated, yeah, and we just create link. If we create a fork, we create a link to the existing LFS object, yeah. We don't re-upload it once again for the fork.
Yes, that's
correctly. Yeah.
That's correct.
Yeah, that's great.
Sean?
Yeah, so I actually got two questions, if that's okay. The first question is actually just following on what Igor just said. So do we know, and maybe this needs some more thought, but do we know if once we've forked a repo that includes LFS objects, and then a new object gets added to the fork, where is that going? Is it being added to the primary repository's LFS storage?
So the new object it gets uploaded, and then it's, as soon as you upload the file, I guess referring back to this slide, this step actually will create that LFS object and link it to the project. So it will be associated with the fork and not the upstream project.
Okay, right. So then in terms of, because this original question was who's paying for it, and so that would then count against the fork. The forks. Yes. Okay, and then when the fork was, or I guess when the pull request was merge request was merged, then do we know if it then goes to the primary? Or it'd be in both places. Yeah.
Actually,
sorry, maybe I'm not being clear. So we have a fork, and then we have a branch on the fork, and then we put a new LFS object in that forked branch, but then we request to merge that back.
Okay. Yeah, I guess just to explain the fork, when we fork it, so when we're talking about how we count storage, it's like we sum all of the sizes of the LFS objects associated. So for the fork, when we create the fork, we link all of the LFS objects from the upstream project. So the fork starts off with LFS storage that's like kind of overstated. Like we're not storing extra for the fork, but we're considering all of these things. And then when you add something to the fork, that is for the fork itself. But then when you create the merge request, then that LFS object that's in the diff of the merge request is linked to the upstream project. So not even when you merge it, creating a merge will, I guess, use storage of the upstream project.
Okay, so that poses an interesting question then, because or quandary, because in theory then like a public project could be forked. I'll take my hand down. Public project could be forked, and then someone could just upload arbitrary files, and that would actually count against the primary project's budget, I should say, or size of the repo.
Yeah. Oh, yeah. That actually brings up another thing that I forgot to mention. Trying to remove LFS objects is actually kind of mysterious. Like in our instructions, I guess, it's just kind of like, this is how you do it. You just go through these steps, and then you run our repository cleanup. I didn't really figure out where this goes. It kind of disappears into Gitly somewhere. But it is kind of mysterious how it works. So if someone were to do that, that is like create merge requests that link LFS objects to your public project. I'm not sure how you as a user might be able to mitigate or deal with that.
Does anyone know how? Does anyone ever run this repository cleanup or know how it works? Anyone else?
Yeah, I did that, but so what it does, like behind the scenes, so we create like a special file, this like from this filter repo. There's like a couple of ways how to do that. So we create a special files that create like a kind of mapping between the old commits and the new commits, and kind of allows us to remove some of the commits from the repo. And we upload that to one of our endpoints that provides that to Gitly. And on Gitly side, we basically execute this git garbage collection command with specific flags. Basically, might miss some parts, but in general, it works or something like that.
And we run this from the command line. How does someone initiate this?
The Gitly runs that, and Gitly has like the direct access to the Git execution file. Basically.
So it's a background housekeeping process.
Yep.
Okay. And there's also some fields in the settings. I guess either housekeeping or cleanup. This is actually we just like here. So I keep.
Sorry, Igor, I didn't hear that.
Oh, yeah, I mean, Jerry already is showing it on the screen. So I was talking about this field. Yeah. So this field allows us to upload the file.
We initiate it.
Object name generated, and then Gitly performs the comments based on those files. And since I started talking, one quick note regarding the duplication. I haven't touched the code for a while, but now I quickly checked. We do duplicate in the LFS objects globally. Like we have SHA 256, yeah. So that allow us to state that the file that it's unique. SHA is unique for a file, yeah. So we can store them globally, and then if someone uploads a file that already exists in the system, we don't like duplicate the file. We just use the existing one. And of course, there's a security concern that someone could just upload the SHA, and just receive the file that is already uploaded somewhere in another project. So in this case, we just download the file from one place and compare it to the file that is being uploaded. And only if they match, we create a link and duplicate the objects. So regarding who's paying for that, honestly, I don't know the details of our business model regarding the storage, but if someone pays for the LFS storage, then we just calculate how many files were uploaded for this specific project. Yeah, if it was 4, then we state that the user uses the same amount of data, the same amount of storage. Yeah, we duplicate it in the background. Yeah, but to user, it's shown as it's displayed as if you fork the project, you used two times the size of the project. So
yeah, I think that's thank you, Igor, that's really helpful. I think what you're pointing out is also what originally spurred the investigation into this, because we're effectively overcharging. I do have another question, but I'm happy to wait until someone else has a question. I don't want to dominate the floor. No one else has another question? Okay. In that case, Jerry, would you mind just going back to the diagram? So you mentioned something about Workhorse had already uploaded the file. So is this essentially in parallel? Once the file comes up, it goes to Workhorse, and then Workhorse does the upload, because that upload could take some time, right? Depending on how big the file is. And then it creates the pointer, or how does that work? Or does anyone know? Like say we do a push, and so can a push contain both LFS and non-LFS objects in the same push?
You can. I'm not sure what order it happens in. This kind of looks like it happens at the same time, but I kind of doubt that a little bit.
Because I'm just imagine there's a multi-megabyte, let's say 50 megabyte file. So the push, even if it's going through Workhorse into object storage, it might still be slower than just pushing a small text file directly to GitLab shell. So does that whole thing get treated as a single? And maybe someone else on the call might know the answer to this as well. Does that whole thing get treated as a single transaction from the terminal? And in the same with the Git pull, do we wait for the whole file to come back before we present it to the user?
Yeah, I think so. As far as I remember, it works like Git clone. Yeah, you just see the progress, like you push in the files, yeah, and you see the whole progress that the file is being uploaded. And I don't remember the details of the user experience, user interface, but I guess to user it doesn't seem like it doesn't make much difference. Yeah, that it just user just sees a file being uploaded, and it's just doesn't matter where it's going, to the object storage or to the repository. Yeah, the interface is mostly the same. The file is being uploaded, but in the background, it's not performed in the background, like the user pushed and something happens in the background. It looks like the file the text file goes to Git, and the LFS file goes to Workhorse and being uploaded on the object storage server. So I hope I answered the question.
Yeah, that's great.
So user interface is mostly the same. I hope so. Yeah.
Igor, can you just explain to me again the security feature you mentioned? So in my head, thinking about this, there's basically a big bucket of files, and each repository kind of points to, says this binary belongs to this repository with a file with a hash in it, essentially. And that's how we don't have duplications of files when we fork repos or have any duplication across the complete system. What is, you mentioned there's a security feature to stop a user like faking the hash of a file, although that would be unlikely. Like, how do we mitigate against that again? You say we download the file and we check it against what we're uploading, is it? What they're uploading.
Yeah, like the user uploads, for example, user uploads a fake file, yeah, like a fake file, yeah, content of which, for example, user knows SHA of the file, but a user doesn't know the content of the file. What they can try to do, it's uploading LFS pointer, which contains SHA, yeah. Upload it to Git repository and just upload like a fake file, just to make the appearance that some file is being uploaded. And if, for example, we didn't check the contents on the file, didn't verify the content, we could just, in order to deduplicate the file storage, we could just take SHA and find the object that we need and say that you pointed that file, that is your file. But that would be a security concern because this file is sensitive to user. User doesn't know the content of the file, but they receive it because they specify the pointer. But if we verify the content of the file, when we state that the user knows the content of the file and they upload exactly that file, that helps us to mitigate the risk. Not mitigate, but protect us from this vulnerability.
Yeah, cool. Thanks, man. Sorry, I kind of dropped out a bit there, but I think I understood basically as I was asking the question.
That's totally fine. Yeah, thanks for asking.
Thanks, dude.
Yeah, I had a question about also the same process. It must be very memory intensive to do it, no?
Hash the files would be tough. Yeah.
Yeah.
Depending
I
on
agree.
the size of the file.
Yeah, and I believe we did have some initiatives to optimize it, but I don't remember whether it was complete. Yeah, but it's something that if we haven't performed it, haven't optimized it already, then we still have a plan to do it. Yeah, maybe like check in the part of the file, maybe it would work, but I don't remember whether there were some concerns whether it works or doesn't work. So yeah, but I agree with your point. Yeah, that it can be like too expensive to do it this way. But security is more important.
Yeah.
And Jerry, what are we looking at on the terminal screen there?
Oh, this is just the actual thing that is uploaded to the repo. So this is the hash of the file that's uploaded to LFS and the size, and these are that's basically what's used to deduplicate. So the hash file and the size is what kind of uniquely identifies it.
And within so in that repo you've got can you see locally that it's a LFS object in the repo somehow?
Locally, I'm not sure if you can actually tell. Like they look like regular files.
They look like regular files. Okay, cool. Well, that was really. Yeah, sorry.
Can I just one more? Sorry, Sean. What is the
No.
what is the like how do we sell this to customers? Like how do they pay for that? Do they pay for like I've got 2 gigabytes of storage for binary files, or this is an option they can add into, is it? And the question is, if we have this deduplication system, who pays, the first guy or the second guy? Is it?
Yeah, that's a great question, Gavin, and that's in fact what started the issue that Jerry was working on, or in fact there's even an upstream issue about how we are billing for this stuff and whether we should be charging, because object storage is cheaper than regular storage, and should we be charging separately? And then the current iteration is we're just applying some type of factor, but I think we will actually eventually get to a more exact accounting for this stuff. Yeah, but we're not really super precise at the moment. In fact, we're so imprecise, the issue was to investigate how we're charging for it.
Yeah, okay. So this is the initial investigation into how to be more precise, I guess, isn't it?
Exactly. Yeah. Jerry, that was really awesome. A really awesome talk. Thank you so much for presenting it. Really good. And yeah, just want to mention everyone that was Jerry's first presentation. So hats off.
Yeah, thank you very much. Yeah.
Nice
Thank
one.
you.
Nice one.
Thank you.
Is there anything else to add? We'll stop the recording. I'll stop the recording.